Assalamualaikum. My name is Putri DAYINI binti Muhammad Noor. So today my crew and I are going to present about analysis of vanillin in white chocolate by gas chromatography. So let's get started. Okay, the first one is introduction. Okay, what is gas chromatography? Gas chromatography is a separation technique that uses differences in boiling point, vapor pressure, and polarity to separate components in mixture. It is also known as gas liquid chromatography or GLC. Okay, this type of chromatography uses a liquid stationary phase and insert gases mobile phase. Okay, as you know, vanillin used as flavoring additive in food industry and extracted as a sample using SPME through a fused silica fiber coated with divinyl benzene. Okay, so let's see the principle of gas chromatography. Okay, as you can see in the picture, a sample is introduced into the inlet of a GC through injection port, and then the mobile phase carry gas enter through intake and swipes the sample into the stationary phase known as column. As the combination passes through the column, it undergoes chromatographic separation. When it leaves the column, it passes through detector which generate an electrical signal proportional to the number of eluting analytes.
Hi and Assalamualaikum warahmatullahi wabarakatuh. I'm Aina Sofea binti Muhammad. For this part, I'm going to talk about methodology sample preparation for this gas chromatography experiment. For the first step, 1 gram of white chocolate is shredded into a fine powder in a mortar and transferred to an aluminum flask. For the second step, the sample is diluted with a low boiling point and internal stranded. The mixture was stirred to require a homogeneous solution. For the last step, in this experiment, the solution separated by using the decantation method and organic compound has been analyzed.
Gas chromatograph coupled with mass spectrometer (CMS) with EI sources and CTC 3-in-1 autosampler was applied to quantify the content of vanillin and ethyl vanillin. The samples were incubated at 80 Celsius for 40 minutes with a rotation rate of 500 rpm. After incubation, a 65 nanometer DVB PDML fiber was exposed to the headspace of the heated vial for 40 minutes. The fiber was then dissolved in the injection port for 5 minutes. Data were collected using chem station Sofea. Ultra-helium 99.999% passed through a gas clean GCMF filter and was used as the carrier gas at the flow rate of 1 ml per minute. The injection volume was set at 1 nanoliter with a non-splitting mode, and the injection port temperature was held at 260 Celsius. A capillary column was used for separation. The initial oven temperature was set at 80 Celsius with an initial 2-minute holding, followed by a program temperature ramp at 15 Celsius per minute to 280 Celsius and was held at 260 Celsius for 2 minutes. The interface temperature was set at 275 Celsius. The monitoring iron were used as follows. The solvent delay was 5 minutes, and the chromatogram of the sample and the mass spectra of vanillin and ethyl vanillin are shown. And under the above chromatographic condition, the baseline totally disunited between the peak of vanillin 9.647 minutes and the ethyl vanillin 9.973 minutes.
In this experiment, we can discuss the result that we found. According to the law of similar mutual solubility, non-polar fiber coating had higher extraction efficiency for non-polar volatile compounds, while polar fiber coating had higher extraction efficiency for polar compounds. The study was conducted under the following parameters: temperature at 70 degrees Celsius, oscillator rate at 500 RPM, incubation time for 10 minutes, and HSSPME time for 20 minutes. Under these conditions, the extraction effects of 7 different types of extraction fibers on a matrix standard mixture solution were tested.
Results and discussion. Graph A extraction fiber. The result indicates that the peaks of the analytes obtained from the 7 different types of extraction fibers were well separated. Hence, the 65 micrometer was chosen as the best extraction fibers based on the results. Graph B extraction time. The high temperature could lower the partition coefficient of the extraction fiber and reduce the extraction efficiency. Hence, the results indicates that the peak areas at 80 degrees Celsius.
Hi, my name is Nadia. I'm going to conclude this experiment. Overall, the objective of the experiment was achieved. In this study, a method for determination of vanillin and ethyl vanillin in white chocolate by using auto HSSPME GCMS was established. This method eliminated the interference of complicated matrix in white chocolate by simple pre-treatment. The spike recovery of the sample was ranged from 90% to 100%, and the RSD ranged from 1.9 to 5.1%. The LOD was 0.1 and 0.05 mg per kg. Both vanillin and ethyl vanillin perform good linearity within the range of 0.1 to 2 mg per kg and 0.05 to 2 mg per kg, and calibration coefficients were 0.9992 and 0.9991 respectively.
Hi and Assalamualaikum. My name is Putri Daini Binti Muhammad Noor. So today, my friend and I are going to present about determination of vanillin in vanilla essential oil by using high-performance liquid chromatography, or known as HPLC. Okay, so let's dive into the introduction first. Okay, what is high-performance liquid chromatography? Basically, HPLC is a form of chromatography used to separate compounds that are dissolved in a solution. HPLC separate compounds dissolved in a liquid sample and allow qualitative and quantitative analysis of what component and how much of each component are contained in the sample. Okay. The solvent used to separate component in a liquid sample for HPLC analysis is called the mobile phase. The mobile phase is delivered to a separation column known as the stationary phase and finally passed to the detector at a stable flow rate controlled by the solvent delivery pump. Let's see how high-performance liquid chromatography works. Okay, first and foremost, sample is introduced into column with mobile phase. Next, separation is accomplished by different moving speed of each compound. For your information, in the column, the stronger the affinity or van der Waals force between the component and the mobile phase, the faster the component moves through the column along with the mobile phase. On the other hand, the stronger the affinity with the stationary phase, the slower it moves through the column. And finally, the detector will connect it to the outlet of column, monitor each electing compound from the column.
For this part, I'm going to talk about methodology sample preparation for high-performance liquid chromatography. For the first step, the crude and ripe vanilla pods were macerated in dehydrated ethanol for 10 to 12 hours at room temperature. The extract was filtered through a 0.45 micrometer membrane filter and the solvent was removed under vacuum. For the last step, concentrated extract was redissolved in methanol to get a sample solution of milligram per milliliter and subjected to HPLC analysis for quantitative determination of the compounds.
HPLC equipped with a reverse phase 18 in-cap column, a photodiode array detector, an inlet degasser AF, and a 20 nanoliter loop manual injector, and water impulse software was used for the analysis of phenolic compound. ICN or methanol solvent A and water or acetic solvent B were used as the mobile phase with a gradient illusion. Column was equilibrated under the static condition for 5 minutes. The detection wavelength was set at a 218 nanometer and the column temperature was 25 Celsius and the injection volume of the sample were 20 nanoliter.
In this experiment, we attempt to use a combination of SEN with methanol with 1:1 ratio volumes and 0.2% acetic acid. It proved successful as it allowed the separation of a maximum 21 standard phenolic compounds, even though we run more than 25 phenolic compounds as reported in various species of vanilla. We successfully detected 10 phenolic compounds out of separated 21 compounds. In this, quantitative variation may be due to the differences in geographical locations. 10 compounds were identified by comparison of their rotation times, UVB spectra, and by conjunction with standards. A good linearity was achieved in the range between 0.9950 until 1.0 for all the compounds in Table 2. All the compounds in Table 2 was experimentally verified by 6 injections and found in the range between 0.027 and 0.622 microgram millimeter in Table 2.
Next is discussion for HPLC. The proposed chromatographic method was validated to determine the linearity, precision, and also accuracy of each compound. Vanillin in the ethanolic extract of vanilla pods were quantitated by using the developed RP-HPLC method. In general, the concentration of it was ascertained to be the highest, followed by the other compound, which was shown in the table 3.
Hi, my name is Nadia. For the last part, I'm going to talk about the conclusion. In conclusion, the objective of the experiment was achieved. The pre-extraction treatment for vanilla, about 2.5 cm, resulted in high vanillin content because there is a direct contact between vanillin component in vanilla sample and extraction solvent. The vanillin content resulted from the solution extraction is higher than the percolation extraction. This is because there is a continuous solvent purity process in the solution extraction. Therefore, the density of vanillin in vanilla extract is higher. The HPLC method offers a more accurate means of determining vanillin content in vanilla than the isospectrophotometry because by HPLC method, the vanillin was separated from other compounds.